The challenge for us hiring in Silicon Valley is that for the most part, people have gone completely computer science. And I'm partly responsible for that, right? Certainly that is very valuable. But for the kind of thing that we do, this broad thing that some people refer to as industrial AI, right? The industrial economy. We really need a foundation in physics, electrical engineering, and mechanical engineering, and so on. Actually, what I like to say is when I talk to some of my friends that are mechanical engineers, I said, it's coming back, right? You guys are becoming hot.
Welcome to the Conversations on Applied AI podcast, where Justin Grammans and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Christopher Nguyen. Christopher is CEO and co-founder of AI Automatic, where he's helping businesses harness the power of knowledge-first AI for solutions in predictive maintenance, energy optimization, demand forecasting, and more. Outside of his deep experience in AI, his background includes strategic executive leadership, hands-on software engineering management, and highly available, low-latency services architecture. Thank you, Christopher, for being on the Applied AI podcast today.
Hey, Justin, thank you for having me here.
Well, good. I know you're doing a lot of stuff in AI. It's a booming industry. I gave a quick background around your work with leadership and hands-on software engineering management. I know you've probably been in this field for quite some time, but maybe you could give us a short background with regards to your trajectory to how you got to where you are today.
Well, if I start to where I started, sure. I fill the whole podcast just because of the age. And, I was a refugee child, was dropped in Silicon Valley, San Jose, back in 1980. My first PC was a TI 994A, which predated the Atari. I haven't stopped hacking since. That would be the compact version. But I've been fortunate enough to be, part of multiple waves of technology, all the way from semiconductor, Intel, Xerox, HP, and so on. I've been a professor. I did my undergrad at Berkeley and grad school at Stanford in electrical engineering. And of course, it was hard to do just EE, so it's actually EECS. After the PhD, I went off to Asia, Hong Kong. That was a brand new university starting at the time. This is in the early 90s, the Hong Kong University of Science and Technology. And I was one of the earliest founding faculty members there. And I started a department called the Computer Engineering Department there. But then realized that I actually wanted to build companies, so left and built a couple of companies, which are, again, at the beginning of the internet commercialization. Sold those and then came back to the US. And Google was also just starting. So I ended up joining as an engineering director, then left again and built another company. And that's my current journey, right? The interesting thing about what we do today is you think about how Silicon Valley has gone to, fully digital, right? Software is eating the world kind of mantra. Sure. This project that I have, Automatic, is about applying machine learning AI to the very physical world, the industrial companies. Because my last company was acquired by Panasonic, so that's where I picked up a lot of the industrial AI credentials.
That's awesome. You're speaking to a lot of things that I find fascinating. So my background has been in a lot of Internet of Things. Started my business about, almost 10 years ago or so, working in IoT before it was even called IoT. But what's been interesting is companies have started to put these IoT sensors stuff in all sorts of places, whether it be in your home, in your car.
Yep.
But the industrial space is very unique, right? And now that we're getting this data, now we can start applying a lot of AI and machine learning to it. And you've got the perfect background. I was going to say, computer engineering, those are the types of people that we usually hire out of the local university here because they have that good sort of mix between understanding the hardware side of it, but then also understanding the software side. So maybe you could touch a little bit on how are you guys then positioning your product to be differentiators in the market than a company would just, maybe say, I'm just going to buy something off the shelf, or I'm just going to develop my own. Where do you guys sort of sit in that space?
I'm going to put that, segue from what you say, which is exactly the trajectory, and then put it on fast forward and go right directly to where I say, I don't care how much data you're collecting, it's not enough. And this is the problem that I ran into when this would be in 2016, 17, when Panasonic acquired my company and I helped run global AI there. And we try to solve a lot of these industrial challenges. My mandate was to apply AI, right, across the global business units. And we ran into this problem very quickly. And it's the problem that I just described. And that is the knowledge that is needed, the information that is needed to solve these physical problems do not wholly come from the sensor data that you have of your IoT. It turns out that you really still need domain expertise. You need people that have been learning the physics of these systems, built up experience over 20, 30 years. The data that you have is sufficient only for certain tasks, but not for many of the real challenges. For example, you take predictive maintenance. Predictive maintenance, people talk about that a lot. The real formulation of that problem statement is, can you tell me the probability that this particular pump is going to fail over the next 2 weeks, right? Most of what you know of, I'm going to call it Silicon Valley predictive maintenance, right? Just as an analogy for the digital-only approach, is actually just half of that. It is anomaly detection, right? Meaning, it learns enough about the sensor data so that it establishes what is normal operation. And then when there's something that is out of the ordinary, it'll alert. This is an anomaly. You notice where I positioned that is only half of the predictive maintenance problem, because that's saying, hey, something looks different today, right? Hey, are you wearing your glasses, or something's different about you? But it's not saying that you're going to get sick or exactly your heart condition or something, right? And it turns out that most predictive maintenance is doing that half to kind of short list things to look at today, and then throwing it over to a human expert, right? Because a human expert is the one that that has the actual knowledge and information to solve it. So the holy grail in a problem like predictive maintenance today is, how do we automate? How do we codify what the expert knows? How do we automate that? And how do we scale that? Because the main business problem really is that these experts have become fewer and fewer in numbers, particularly in the US, right, where we have essentially ceased making things for about two decades. And now we wanted to bring it back for geopolitical reasons, for economic reasons, and so on. But whatever it is a very interesting, even exciting challenge, right? But how do you then, take the few experts that you may not have, hopefully that you do, and you scale their talent, across the entire, fleet of vehicles, the entire, set of machinery that you have in your manufacturing operations.
Yeah. And again, it depends on the industry, right? If you're talking about a company that's been around for 50 years that has been doing manufacturing, that they had said, well, there's people on our floor that can, the shop floor or the manufacturing floor, that can just sort of hear when a motor is about ready to go. So they're like, how can we capture that? And of course, there's a digital side to it where you're sort of watching, the current draw, but there's the human side to it where it's just these people have that innate knowledge.
Mm-hmm. That's right. Yeah. And the knowledge, and the reason knowledge is required to make sense is the state of machine learning today is that if you change the model of the engine that you put in there, the data is completely different. To that machine learning model, it might as well be, something operating on Mars, right? There's no transferability between, one context to another. So then every time that happens, you say, okay, well, go collect more data. And by the way, collect 2 years worth of data or 3 years worth of data. Well, I change the model every year. I change the workload all the time. I change in the case of, we also do refrigeration systems, for example, in supermarkets and so on. The workload is different, the climate is different, all those things are different. And yet the physical intuition and the physics that is in the head of these refrigeration experts, they transcend these different machine models and so on. And so they're able to say, well, if the pressure has been dropping for 2 weeks and yet the temperature is remaining the same, I'm going to take a look at the compressor, right?
Yeah.
And so they built up these heuristics over the years. And by the way, semiconductor is going back to the US. There is not a matter of heavy machinery, but precision. Their system is called atomic layer depositions, right? ALD, where you're literally putting down 10 layers of atoms across a wafer surface that is, 12 inch. The precision that is required is, we like to say, it's technology, it is art, and it's also a bit of voodoo.
That's some small scale stuff for sure. So So in that case, you're looking at quality control?
Quality as measured by consistency across, it's almost like Earth, and yet you care about a height of maybe knee deep, right? It has to be completely uniform.
That's an example of a system then that you would come in and help a company using your technology, I guess, to be able to implement quality at that sort of micron level, I guess?
Right. And the way we do it is that we don't, we're a technology provider in that context, right? We don't actually do the ALD physics. So that's the domain of people like Tokyo Electron, Applied Materials. What we help them with is, if you think about the amount of expertise that is required to build the machine, they call them tools, right? To build these tools and then test them, qualify them in volume, and then put them out in the field, and then have other experts, but different kind of experts, use these systems, right? So they would sell into the TSMCs and the Charter Semiconductor and so on. How do these two groups of experts communicate with each other? When they are bottlenecked by time, they are bottlenecked by the numbers. They're also bottlenecked by intellectual property, right? Like they're not incentivized to Intel doesn't want to tell Applied Materials that I'm going to, do this many wafers to do that purposes. So
yeah, sure.
If there's a sort of a virtual expert in between, where the tool maker can share all of their knowledge about building this equipment, where that the process user, the process expert, can leverage that knowledge and do their own work. And now it's much easier to explain what we do because there's ChatGPT. A year ago when I was talking about this, people say, well, there's one group that say, are you building expert systems? And say, no, then what kind of magic is this, right? But now you can see these large language foundational models can help us translate the unstructured expertise, whether it is written in words, documents, or spoken language, into a structured form. And then from that structured form, the other people on the other side, right, can query that, can ask questions. Currently, what they do is they would look up these large documents, right, and then find major sections. It's a very slow process to try to find the answer, if there's an answer in there at all. But now they can get much more consultative, right, by us translating this expertise on the one hand. The other thing they do is they would then build models, AI models, in fact, machine learning models, right, that can leverage both the knowledge as well as the data coming off of the tool.
That's super fascinating because, I was looking at your website and, one of the things you clearly say is no complex coding required, right? So you guys are really kind of trying to democratize, I guess, the ability for people to do some of these things. It's something as complex as natural language processing. And it seems like that's probably one of the key differentiators you guys have. Is that right?
That's right. So with respect to the two use cases that I mentioned implicitly, one is, I call it human to human, right? How do I transfer my knowledge to you without actually having to require that you book a meeting with me, right? And there's only one of me and hundreds of you. So that the human to human knowledge transfer. And the other sort of the human to model, right? A knowledge transfer. How do you share your knowledge, have it translated into some structured form, and that becomes kind of an API that the programmers on the other side can say, I'm going to call into that API and ask it questions, and I don't mean just chatting kind of questions. I mean, like, given this pressure level, what is the ideal temperature, right?
So you guys have an interface like that. You can just, once the knowledge is gained, then through an API, you can essentially simulate what a human would say in that question, in that situation.
A human expert may refer to some physical equation.
Gotcha. That's interesting that you said ChatGPT because, I feel like that has opened up people's eyes to be like, wow, this is what's really possible once you scan the entire internet, right? And get, billions of parameters and whatnot. But do you guys have a software platform that we send all of our data into your system so it can learn it? Or do I train it and then upload the model to you? Maybe talk me through a little bit how it interface with it.
We'll reference ChatGPT because now a lot of people are now familiar with that, right? There's a chat interface, but behind it is this thing called a large language model, right? LLM. Or generally I call them foundation models because it may be images, maybe video and everything, right? So the chat interface is just a user experience. The real, I'm gonna loosely call it knowledge, right, is in the model. Mm-hmm. If you think about carrying that mental model, what OpenAI and Google and Meta have built these large language models that leverages, say, the body of knowledge that is available on the internet. Call that the foundation layer. But then above that, we add domain-specific knowledge. So, for example, we stick with semiconductor. When I play with ChatGPT and I started saying, what do you know about semiconductor and so on? And I said, and now if what's the best flow rate for dichlorosilane if I want maximum absorption, at 600 degrees C? And I say, what the hell are you talking about, Christopher? Right?
Yeah, right. Right.
Right. Now, it could know. That's what we do. We add domain-specific, information. You can think of it as textbooks, industry documents, and so on. And so that layer, that model, that we call a fine-tuned model, now knows something more about that world than the generic-based model. And then in each company, each situation in that industry, they have their own proprietary institutional knowledge as well, right? And so they would add that, and that becomes their model. And so now you have a model that knows something very specific, but also very general about the industry. And then from there, you can generate structured information out of that. And that's where the interesting work begins. The reason I say that is because everything that I've said so far is in the world of large language models. But what most people don't realize who try to build these things is that that's only half, right? The other half is still very much formal architectures of how to combine this knowledge stream with the data stream, right? I spend 5 minutes saying you don't have enough data, but that doesn't mean you don't need it. You do need it. How do you combine the knowledge together with the data so that you can make these predictive decisions? I mean, I can share one example to make that concrete, right? One use case is fishing. I mean, the fishery industry. How does a fish get from the ocean to your dining table? There's a whole industry that supports that. So first is you catch the fish, right? So we work with a company called Furuno to do fish classification. Furuno is a large global giant in marine technology. What they do is they shoot this, sonar beam, sound waves into the ocean, straight down, and then the echo that comes back, right? It forms an echogram that you can print out and you look at the screen. Now, you and I, as amateurs looking at that, we have no idea what we're looking at. Yeah. But a fisherman, right, with 20 years experience would look at that combined with whatever is thinking, going on in their heads about that time of year, that time of day, that location. In fact, they're better than Furuno engineers, right? Because Furuno engineers don't necessarily have all this domain knowledge. They can look at that and they say, that looks like a school of mackerel, right? Or they can say, that's just sand or something like that. Okay. If you try to replicate that and you do it as a computer vision model, right? Remember the computer vision model only has the pixels of that. It does not have the knowledge context that fisherman has. And again, sure. I don't care how high resolution, how many images you take. It's just not in there, right? We can combine what the computer vision model says based on all the standard machine learning techniques where you annotate the image, you train it, and so on. And so the data model will have an assessment of what it thinks it's looking at. And in machine learning world, it says, let's say you're looking at 5 possible species. It outputs 5 probability numbers, right? And the likeliest one is, let's say, mackerel, based on what it's looking at. Now, you have another stream that is coming from domain knowledge. And let's say one piece of knowledge, I'm going to make it very simple. Let's say in Hokkaido, right? This is northern Japan. In November, there is no mackerel. I'm just going to make that up. So then this knowledge model is also outputting 5 species with different probabilities, where the one corresponding to mackerel is 0%. Like there's no chance. And so you can see now you can sort of combine these things, specifically dot product them, right? And so no matter what the computer vision model is saying, I'm sure it's 80% macro. The human model or the knowledge model is saying no chance.
Yeah.
And so the prediction turns out to be more correct than what the computer vision model alone does. I hope that makes sense.
Yeah, no, it totally makes sense. And as you were talking, I was trying to remember the name of the TV show. It was on the Discovery Channel called The Deadliest Catch.
Yeah.
I'm not sure if you ever remember that show, but they had film crews and they were out doing Alaskan, like lobster is what it was. But it was always interesting because it was so much human intuition, right? They were saying, well, at this time of year, these types of seas, and there's a storm coming and we know that it's going to push the lobster this way. Then it was, the goal was to try and catch the most lobster. But it wasn't a computer vision problem. Yes, you need to identify where they're at, but it was much more, these people had been fishing their entire lives out there. In fact, their parents and their grandparents had been fishing as well. And they've handed down all this knowledge, right? So the captain of the ship really was the key differentiator in a lot of these things.
I like your bringing that up. That is such a great context, right? Because if you watch that show, you see some of these decisions are at least, life and death, or at least, livelihoods, right? You make the wrong call, you go home empty-handed.
Yeah, exactly. No, it can seriously be, are you going to have a good year as a company, or are you going to go out of business? So it feels to me like there's this idea of augmented intelligence, right? I've been hearing more and more people sort of use that term, where people get all worried about my job's going away and I'm going to be outsourced because of this artificial intelligence. But I feel like we're working more in this area of augmentation. Do you feel that same way? It feels like your product speaks to that.
I actually like to say that we're not in the AI business, we're in the IA business, intelligent augmentation.
Good. Yeah. Well, it's good. I see you guys are hiring. I mean, I when I was out on your careers page, part of this podcast obviously is just to get the word out, companies that are growing and stuff. Do you have any in particular roles you're looking to fill, or? So
the challenge for us hiring in Silicon Valley is that for the most part, people have gone completely computer science, and I'm partly responsible for that, right? Certainly that is very valuable. But for the kind of thing that we do, this broad thing that some people refer to as industrial AI, right? The industrial economy. We really need a foundation in physics, in electrical engineering, in mechanical engineering, and so on. Actually, what I like to say is when I talk to some of my friends that are mechanical engineers, I said, do you know it's coming back, right? You guys are becoming hot, hard to find. And it's true. Coming back to the semiconductor example, in Silicon Valley today, I should say this with maybe a somber tone, there's been a lot of layoffs, right? And people read about that but you realize it's actually a very specific industry. It's a very large industry. That's the computer software industry. If you look at semiconductor, right, talent is so hard to find that these companies are sort of trying to poach from each other, vertically through the stack, but also horizontally and so on. And so these semiconductor guys are suddenly in high demand again. But certainly what we're looking for is we're looking for people with that combination of computer science or sufficient software engineering background, but equally important. And I'm not going to say machine learning because that sort of can be picked up. The part that is very hard to train on the job is sort of foundation of physics, Maxwell's equations and so on, in order to formulate how to even empathize with our customers, right? That'll provide them with solutions.
Yeah, no, that's really good. So if there's any listeners that are listening that want to check it out, you guys have a link right at the top of your page.
Mechanical engineers, physicists, and so on, electrical engineers that have enough CS to be dangerous, that's what we're looking for. Not the other way around.
Sure, like you said, some of the other skills can be taught. You can take courses on machine learning, that stuff up. Foundational stuff is what's really important. So what is the day in the life of your job as your CEO and co-founder of this business?
Oh, you mean apart from speaking on podcasts?
Yes. Yeah. What's some other fun stuff you do? These podcasts, they're probably not great.
Well, there's standard CEO stuff, P&L, talking with customers, visiting customers, fundraising sometimes, from time to time as necessary, team building and so on. But I think that the thing that, say, across, I built a bunch of companies and teams and I've been a large-scale corporate exec before. The thing that I love about this, and I hope you can sort of feel it as I talk about it, right, is the discovery, right? And discovery while solving somebody's, real world problem. I have a team working on, so I mentioned fishing, I mentioned semiconductor and so on. Another example is we're working also with an industrial company on predicting adverse, extreme weather, right, for the purpose of pushing that button and say evacuate. It's very clear that in the last decade or so, there have been a lot more extreme weather events. Whether it's here in the US, we call them atmospheric river. Elsewhere they call them linear rain belts that have resulted in floods that are, unprecedented in places that you don't expect, like downtown Seoul, for example, was flooded, right? So one project is about trying to, predict that. And of course, you don't want to push the button all the time and cause evacuation of the whole city of Seoul. But if you don't do it, then people die, right? So that's an example where the team and I feel very motivated to say, wow, this is actually cooler than inducing people to click on one more ad.
Yeah, sure. I love it. I mean, the best jobs that I've had in my career were ones that I felt like were impacting the world. There's no one size fits all with this, right? You're kind of going into these companies and having to help them on a unique custom basis. Is that true, or do you have some sort of basic framework that you can use or stuff like that?
Right. So we are a software company. So everything that I've said, the domain specific stuff, that doesn't come from us, right? We provide them with this tool, and at the core, what the tool does is enable this translation of domain knowledge into the structured form. And then B, from that structured form, can be queried by other engineers, other software people, or built into a model, right? A predictive model that would be much more accurate, let me put it in a simple way, than if you did not employ human knowledge. So that's the tool that we have. It's a software platform. Now, inevitably, as we work with our customers, we pick up, domain knowledge. And so, on my own background, for example, I really understand semiconductor. That's what my PhD was about. So as we deploy this across the market, there's going to be, we can't boil the ocean. So we're going to develop some vertical relationships with different industries. So that's whether that's semiconductor, oil and gas, cold chain, meaning the refrigerated supply chain in manufacturing. Right? But there are others that we don't yet engage in because simply we don't have the bandwidth.
Yeah, it seems like, there's people are going to need some hand-holding along the way. I mean, we talk about working in some of these specific things. You guys have a professional services team that maybe helps get people going. Once they understand the tool, they can kind of be off on their own. But
that's exactly right.
You guys can stay engaged with them to begin with.
We call that team the AI solution engineering team, and they work with our product team.
Gotcha. Where do you see your tool then going in the next 3 to 5, 10, whatever years?
Well, 5, 10 years, hopefully everywhere, right? And the interesting thing is that we are the pioneers in this point of view at a time when most of Silicon Valley is still saying, more data, better data, collect better. It's all true. It's necessary. It's not sufficient. But I have no doubt that others are thinking the same way, and they are intuitively building in this direction as well. That reminds me that there's a conference that we help sponsor and manage called the Knowledge First Conference. The first one was in 2022, November. The one that's coming up is going to be October. And that's where it's kind of a birds of a feather gathering. People that are really interested in industrial AI have been solving or trying to solve it in different ways. We come and we share ideas and so on. My favorite comment from a gentleman named Chetan Gupta, and he is the head of global industrial AI at Hitachi, right? His office is just down the street, Santa Clara here. He says, now that I come here, I realize I don't want to go to any other AI conference. I feel like I'm among my people. The other ones are important too, right? But they serve completely different purposes, whether it is advancing the state-of-the-art machine learning techniques, or whether it is a trade conference. The Knowledge First World, and by the way, the URL is k1st.world, is for leadership in business, in government, in industry, and so on to get together and share war stories that mostly a failure up to this point, right? And hopefully the software that we're building will enable more successes. Certainly, among people that share this point of view, that you really need to add knowledge, domain knowledge, to your data in order to solve real-world physical problems.
Yeah, this is fabulous. I'm looking at the website right now. I see your face there at the first level, but you got people, from MIT, Columbia, Stanford.
The NSA as well, right? You see that?
No, it's got awesome. And I see there's a guy I know, Pete Warden from Useful Sensors. He basically wrote the whole book on TinyML.
Yep.
He's been on this podcast before, actually, and I teach a class on IoT and machine learning at the University of St. Thomas here in St. Paul, Minnesota, and I actually contacted Pete and see if he would be a guest speaker, and he said yes, which was awesome. Like the guy that wrote the book on TinyML actually came in and spoke to my students via Zoom. But I mean, my whole class is all around TinyML. So man, this conference looks great. So you guys are planning on doing it again in fall of 2023?
That's right, October.
Perfect. Was this in the Bay Area? Seems like
this will be. Yeah, the location is Stanford University.
Stanford. Okay, yeah. Interesting. Cool. I'm always looking for a good conference, so I will definitely put this in the liner notes for other people to see. And yeah, I went to the TinyML conference last spring, which was awesome, but I missed it this spring. So this would be a great AI related IoT conference. Perfect.
Yeah, Pete spoke at the K-First World as well, and he talked about useful sensors. I'm on a mission to make everything creepy. meaning, when your fans start, responding to you, right? He wants to, wave a hand and the TV should turn on and talk to your light bulb. Of course, there's beginnings of that already, Google Home and so on, but useful sensor is about putting all of it into every device everywhere. Your environment will start responding to you.
Yeah, running these models at the edge and being able to let them run for years on battery power, right? So that's when things get interesting, is when they're not connected to any power anymore and they can run for a long period of time and respond to stuff, not even over the internet, respond to stuff on their own. So
we may become
cool.
more attached to our fans, right? Because we anthropomorphize everything.
Well, good. So one of the things I'd like to ask people maybe at the end of the podcast is like, so if I'm a person coming out of school today, where should I be looking for resources to sort of like learn this stuff? I mean, obviously there's your company, but I mean, what advice would you give to college graduates or even people that are studying school today? Obviously, you mentioned computer engineering as a good field, but even if I get out with a computer engineering degree, what are some interesting pockets or interesting publications? I mean, you mentioned a conference, which is awesome. Where should I be looking?
Well, narrowly, you should be looking at Itomatic.
Uh-huh.
We do take interns, right hand of the distribution. But I think generally the interesting thing is that it is not about a role or a job. It's about connecting yourself to the new economy versus the old economy, right? I think it's an exciting time for young people, but it's also a very scary time, right? I have friends that have kids at CMU studying computer science, and ChatGPT came out. And that son called his dad and said, "Does this mean I'm not gonna be needed anymore?" Right? I think that's worth thinking about. But I think related to this knowledge first AI or knowledge first sense that we have, I think humans will always be needed. Right? Certainly with large language models, a lot of things that are sort of lower skills will become more and more commoditized. But there's always got to be this top executive layer. So people say, when these machines can do everything, what is there for humans to do? Well, I said, one of our job is that executive function, not just the answers, but prioritizing the answers and choosing among the answers, right? And asking the questions. I think that's going to be even more needed in this new economy, right? So the premium for that is going to be very high.
I mean, that's one of the things I've been hearing, like ChatGPT, it's amazing, but you got to prompt it, right? You have to ask the right prompts. If you don't understand the right questions to ask, it's useless.
Right.
So yeah, you're going to need people that are going to have to actually understand, think about how this technology can be best used. It's not just going to automatically implement itself. So that's definitely wise words. Well, are there other things you want to talk about, Christopher? I think we touched on a lot of stuff here.
Yeah, I'm good. I mean, I would appreciate if people go to Itomatic. It's like automatic, but starting with AI. So itomatic.com and check us out. Particularly potential industry leaders that hear this and find that we may offer something of interest, or even that the problems that I'm talking about resonates with what you have seen. And by the way, that's where the conversations flow the best. People who have tried and failed, and so they know exactly what I'm talking about. And say, okay, then tell me about your solution, your approach.
Yeah, for sure. I mean, you have to expect implementing any new technology, there's going to be a series of, there's sort of the Gartner hype cycle, right? Things kind of fall into this trough of disillusionment, and AI has gone through a number of different winters, but I feel like we're I don't know, everyone that I talk to, everyone's been on the podcast is, yes, there's been a lot of trials and tribulations, and there will continue to be things that don't work well, but it's really starting to pay off here. We're seeing a lot of great applications of it.
Well, as you mentioned, ChatGPT itself is going through its own hype cycle.
Yes, I think it's actually overhyped right now, right? It's everyone says it's going to do everything that it really possibly can't do. And it's not even, we haven't even talked about artificial general intelligence, but it's not there. But people are starting to believe maybe it is. That's a whole different subject, AGI.
Well, mark my word, there's a very simple mental model with it where large language model and ChatGPT is just the first half. You need the other half.
Great. Yeah, that's a great point that you've made. And yeah, that's been sort of the foundation of our conversation today, is you have to have that industry knowledge. So, well, cool, Christopher. I appreciate the time. Thank you so much for sharing with us your experience, and good luck on your company. It sounds like this is probably, one of many, many companies you founded. So excited to see what happens with your career in the future. I'm sure this is not your last company, but good luck. And yeah, we have liner notes. So we'll have a link to your website, a link to the careers page, link to the conference, the Knowledge First World Conference. And yeah, thank you so much for being on the program. Appreciate it.
Awesome. Thanks again.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.